we have discussed about the capacitance, and the passive component which offers this capacitance is called as a capacitor. Here we are drawing the circuit symbol of a parallel plate capacitor. In this parallel plate capacitor, we are having two metallic plates. This is one metallic plate, the second one, this is another metallic plate. We are assuming that the both metallic plates are made with the same metal. And if in between these two metallic plates, if we use an insulator, this combination forms a capacitor. Two metallic plates and an insulator, this combination forms a capacitor. This capacitor offers a capacitance C, and the capacitance is we are representing with the letter C. Resistor, when we connect the resistor in a circuit, we use the letter R. When we connect some inductor in the circuit, we use the letter L, where R is the resistance offered by the resistor, L is the inductance offered by the inductor, and C is the capacitance offered by the capacitor. And this capacitance offered by the capacitor is measured in the units farads. In generally, we have the capacitors in the range of microfarads, nanofarads and picofarads, and all these capacitors that are offering, example in the microfarad range means we use the 10 to the power minus 6, and nanofarads means 10 to the power minus 9, picofarads means 10 to the power minus 12. These capacitors we use for a specific applications that we will discuss later. And why we call this material as a dielectric material? Because this is an insulator. Why we are not calling this is an insulator, especially in the capacitor? Why we are calling this as a dielectric material? As we discussed in the last class, when we connect a battery to this capacitor, because this metallic plate, we are assuming that all electrons are hitting on this metallic plate. So the negative charge is observed on this metallic plate, and we are observing electric field lines are originating from the one plate and they are reaching to the another plate. So this dielectric is storing the electric field lines. Only insulator has the capability to store the electric field lines. Metal, conductor cannot store the electric field lines. If we use a conductor, then the electric field line after hitting the conductor, it reflects. So in the conductor, in the metal, we cannot store the electric field lines. Only the material in which the electric field lines can be stored is insulator. So why we are calling this insulator as a dielectric? That's what we are discussing now. So this plate is a negative plate, and because the origin of the electric field lines must be positively charged particles, we are saying this plate is positively charged. So the electric field lines are originating from the positively charged plate and they are reaching the negatively charged plate. The dielectric material, which we are calling the insulator is storing the electric field lines. Because this insulator we have kept between the two differently charged metallic plates. One is positively charged metallic plate and the second one is negatively charged metallic plate. This insulator is specially called as dielectric material. This dielectric material does not conduct the current, but this dielectric material has the capability to store the electric field lines. This is the reason why we are calling this insulator, which we placed in the capacitor, as a dielectric material. Based on different dielectric materials we use, we have different types of the capacitors that we will discuss later. Farad, already you might know about Michael Faraday, the laws that was proposed by the Michael Faraday. So to give respect to him, we have taken a unit for the capacitance, that is Farad.